Earth is moving through space at about 107,000 kilometers per hour. You don't feel it. You don't notice it. But every second of every day, our planet is racing around the sun along a delicate gravitational path. That motion is what keeps Earth at a safe distance from the sun. Warm enough for liquid water, but far enough away to avoid burning. But imagine something impossible happened. In a single moment, Earth's orbital motion suddenly stopped. Not the planet spinning on its axis, not the sun disappearing, just the sideways motion that keeps us orbiting the sun. What would happen next? Would Earth drift harmlessly into space? Or would we begin falling directly toward the sun? The answer is far more dramatic than most people realize, because orbiting the sun is really just a constant state of falling. And if that sideways motion disappeared, the balance that keeps our planet safe would instantly collapse. Earth stays in orbit because two forces are perfectly balanced. Gravity pulls our planet toward the sun, while Earth's sideways motion keeps it moving forward fast enough to continually miss it. It's like throwing a ball sideways so fast that it keeps falling toward the ground but never actually hits it. That is exactly what orbiting is. If Earth's orbital velocity suddenly dropped to zero, the planet would no longer be moving fast enough to miss the sun. Instead, Earth would begin falling directly toward it, immediately. There would be no pause, no slow drifting through space. Gravity would take over instantly, pulling our planet inward along a new path straight toward the center of the solar system. At first, the change might not even be obvious to people on the surface. But in space, Earth's trajectory would have completely changed. The clock toward disaster would already be ticking. Once Earth's orbit stopped, gravity would accelerate the planet toward the sun faster and faster. At first, the movement would be gradual, but as the distance closed, the acceleration would increase dramatically. Earth would gain speed every second as it fell deeper into the sun's gravitational well. In fact, scientists estimate that it would take roughly 2 months for Earth to collide with the sun if our orbital motion suddenly vanished. 2 months might sound like a long time, but in cosmic terms, it is incredibly fast. During that time, the environment on Earth would begin changing rapidly. The closer our planet moved toward the sun, the more intense the sunlight would become. Solar radiation would increase, global temperatures would begin to climb, but the most dramatic changes would arrive much later in the fall. Because for the first few weeks, Earth would still be relatively far from the sun. Life might continue almost normally at first, but the slow approach toward catastrophe would already be underway. As Earth spiraled closer, the amount of solar energy reaching the planet would increase dramatically. Even a small decrease in distance from the sun means a large increase in heat. Within weeks, average global temperatures would begin to rise. Ice sheets would melt faster. Ocean temperatures would climb. Weather systems would become increasingly unstable. Eventually, the warming would accelerate into a runaway effect. Oceans would begin evaporating at faster rates. The atmosphere would trap more heat as water vapor filled the sky. Cloud patterns would shift, storms would intensify, and ecosystems around the planet would start collapsing. But even these changes would only be the early stages of what was coming. Because the closer Earth moved toward the sun, the more extreme the environment would become. By the time Earth reached roughly half its current distance from the sun, the planet would already be entering an environment far hotter than anything life has experienced. Surface temperatures would climb beyond survivable limits. Oceans would begin boiling away. Massive amounts of water vapor would fill the atmosphere, creating a dense blanket that traps even more heat. The sky itself would begin to change color as the atmosphere thickened and sunlight intensified. Any remaining ecosystems would collapse under the extreme temperatures. Plants would wither, animals would struggle to survive. Human civilization would face conditions far beyond anything technology could easily manage. And still, the fall toward the sun would continue. As Earth approached the inner regions of the solar system, the environment would become unimaginably hostile. Temperatures would soar to hundreds of degrees. The oceans would completely evaporate, leaving behind a dry and scorching world. Eventually, the atmosphere itself would begin to escape into space as solar radiation blasted the planet. Earth would slowly transform into a barren, overheated rock. And then, after weeks of accelerating descent, the planet would finally approach the sun's outer atmosphere. At that point, tidal forces and intense heat would begin tearing the planet apart. Earth would not simply crash into the sun like a solid object. Instead, it would break apart, vaporize, and dissolve into the blazing plasma of the star that once gave it life. Thankfully, this scenario is purely hypothetical. The delicate balance of gravity and motion that keeps Earth orbiting the sun is extremely stable. Our planet has followed this same path for more than 4.5 billion years, and there is no known force capable of suddenly stopping Earth's orbital motion. But this thought experiment reveals something fascinating about the universe. The stability of our world depends on motion. Earth survives not because it resists gravity, but because it is constantly falling through space in just the right way. Remove that motion, even for an instant, and the balance that keeps our planet safe would vanish. In space, stability is often just a perfect balance of forces. And the world we know exists because that balance continues uninterrupted every second of every day.